All right, kiddos. So we're back for the final tutorial for our properties and atomic mass unit, that kind of stuff unit. All right. Here on Sunday with 9 days worth of stubble. All right. Well into my beard growing phase right now. What you guys need to have in front of you, of course, get your periodic tables out. That's going to be important for what we do. We're going to focus this tutorial on ChemQuest number 7. That skill practice, that last page, that one I make you guys turn in. We're going to do number 1 and number 2 together. They're very similar problems. We're just going to get some extra practice. That's the goal here. And then, of course, calculator. Make sure you got that handy. So periodic table, ChemQuest, turn to that last page. We're going to do 1 and 2 together. And then you need to have a periodic table in front of you as well as a reference. All right. So we will get started on number 1, and this is, if you guys recall, we're doing weighted averages. So it's not the same as your traditional average. It's taking into account what are the different isotopes that we have, and it also accounts for how abundant those are, because that will affect our overall average. So in a normal average where you add some numbers up and then you divide, okay, this, you multiply some numbers and then add. No dividing. No dividing for our weighted averages, at least not this way, not this method, okay? So, question 1, I'm just gonna read it. It says, a certain element exists as 3 different isotopes. 24.1%, whoops, of the isotopes mass is 75.23. I need to fix that number, silly Mr. Huberberg. All right. 48.7% have a mass of 74.61, right? And 27.2% have a mass of 75.20. All right, so I wrote it out like that just so I don't have to pay attention to all the ifs, ands, and nuts. That's the information I need, all right? Also, if you haven't done this actually too, I didn't even think to mention this, maybe hit pause, go back and find your notes, those 5 steps for how to do weighted averages, right? So, pause. All right, we're back. All right, so we've got this information from our question. That's the stuff I give you, right? So if you recall in those notes, steps 1 and 2 for how to do weighted averages are given to you in the problem. Here are the values we want to average, and these are the percents, okay, which are recorded as percent abundance. All right, so with that being said, we're going to move right to step 3. And step 3 is to convert the percentages into decimal form, right? Which just simply means 2 decimal places to the left. All right, so I'm going to rewrite these percent values over here in decimal form. So 24.1% are this atomic mass, right? So I'm going to convert 24.1, right, into 0.241. All right, I'm going to then convert 48.7 into 0.487, and then 27.2%, okay, abundance into 0.272. All right, now you guys may have noticed I wrote that little multiplication sign down there because I'm anticipating that next step, which I'm going to take. So that next step involves multiplying, right? So again, we convert our percent abundance into its decimal form. Then we're just simply going to multiply those numbers. Like I said before, instead of adding and dividing with weighted averages, we're going to multiply and then add last. All right. So what I can do in this case is go ahead and multiply my numbers, right? So I got my calculator. I'm going to go 75.23 times 0.241, and I get 18.13. All right, then I'm going to go 74.61 times 0.487. That gives me 36.36 if I round that, and then 0.272 times 75.20, that gives me 20.45. All right. Now, multiply, so that was my step 4. I'm going to multiply my value, which is my mass, by its decimal abundance, not the percent abundance, right? And those are my 3 numbers. So we multiply and then we add those up. So when I add those up, I go 18.13 plus 36.36 plus 20.45. I get 74.94. Okay? And that is my atomic mass. Now, depending on how you round, now you could have done all this into one problem, right, and not round it until the very end, in which case you'd get 74.92, right, which is actually a little bit more accurate. I just wanted to show where those numbers came from. When I show the next one, I'll do all of this just kind of in one problem, okay? But anyways, so 74.94 is what I get when I round first and then add. 74.92 is what I get when I round at the end. But they're both pretty darn close or similar to each other, all right? It's just that rounding at the end is actually a little bit more accurate, or we're not rounding too often. Now, what we're going to do then, for step B there, it says, use your periodic table to determine which element this is. So I'm just going to look at my average masses from my periodic table, and hopefully this number, actually this number right there, matches what I find on an element on the periodic table. So scan, scan, scan. They pretty much go in order. The bigger the atomic number, the bigger the mass. And I land, ooh, look at that, arsenic. Okay, symbol AS, which is number 33, has an average mass of 74.92. That is definitely matching up well with that value and pretty darn close to that value. All right, so looks like my math makes sense. So the answer to number one, letter B, is arsenic. All right, so next we are going to do number 2, which is a very similar problem. I'm just going to have to erase for a second. And my board is not wanting to erase, so I'm going to do this. All right, problem solved there. Next question is, an element exists as 4 different isotopes. Okay, so in this case, I've got 4.35%. Okay, a lot of them are 49.9461 AMU. All right, 83.79% are 51.9405 AMU. 9.50% are 52.9407 AMU, and 2.36% are 53.9389 AMU. All right, so those are our values, right? Our AMUs are our masses. These are our percent abundance. Now, when you get a question like this one, there's a standout isotope there that's obviously way more common than the other ones, and that would be this one right here, the 51.9405. All right, at 83.79%. So we can kind of make a mental note of that, because when we do our weighted average, since this is by far the most common, we're probably going to get a weighted average that's close to that number, right? Maybe a little higher, actually. Maybe a little lower, probably higher because we have more over here on the high end, all right? So our average should come out close to, but maybe a little higher than that number. So that's a quick way to check your work and make sure, you know, you didn't get a calculator error that didn't make sense, okay? Now, this time what I'm going to do is, rather than setting it up into individual multiplication problems and then adding everything, right? I'm going to do it all in one. All right, so just keep in mind, I'm doing this times decimal, this times a decimal, this times a decimal, plus, 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 plus as I go. So you can enter that in your calculator if you use percentages. Okay, or sorry, not percentages, parentheses. Vocab error there, okay? So, do I know my values? Yes. Do I know my percent abundance? Yes. Step 3, convert the percent into decimals. So I'm gonna do that real fast. 4.35%, I'm gonna go times 0.0435, right? And this is 0.8379. This is times 0.0950, and then times 0.0236. All right. Now, what I'm doing with these numbers, right? I'm going to go this times this plus, this times this plus, this times this plus, this times this. I'm just going to do it all in one step. All right. And what you can do on your calculator, right, is use the parentheses function, right? So you go parentheses 49.9461 times 0.0435 parentheses. So it'll look like that. All right. Then I'm going to go plus parentheses 51.9405 times 0.8329 parentheses. Right? So now it looks like that. All right? And again, I can go plus and so on down, right? I keep entering that in just like it looks here, using my parentheses on both sides and then hitting plus in between. And the number I get at the end, when rounded, should come out to 52.00 AMU. All right? And now we can check our work. Does that 52.00 pretty closely match our most abundant isotope? That's pretty darn close, right? Off by just about 6/100ths of an AMU, right? And again, this is our biggest abundance, so we'd expect our number to come out close to that. But because we have some extras on the higher side there, we might expect it to be a little bit higher. Boom, that matches our prediction very nicely. Okay, so that puts us at 52.00 AMU, and again, I can go to my periodic table, which is rounded to 2 decimal places, and I'm going to try to find an element whose average atomic mass comes in. At least if it doesn't match perfectly, probably pick one that's closest to that, right? So I'm going to scan, go up in order, and I land right there on number 24, which is chromium, whose average mass actually comes out identical to that element we found right there. So that makes this mystery element chromium. All right, so that is it for average atomic mass, which, if you remember, is a weighted average because it accounts for the different values and how abundant they are. All right, so this is the last lesson for this unit, so that test is coming up pretty soon. All right, I should have told you all that in class as far as when that actually is. I will have some review materials for you guys Monday. So you guys keep after it. Hopefully you spend some time over your weekend on chemistry. All right, catch up.